Hello everyone, welcome to Learn Overflow. In this video, we will discuss another LeetCode problem. That is the design a circular tree. This is a medium level problem, and we'll understand how we can solve this question and how to think on finding a solution to this kind of questions. Okay. So before moving on, if you haven't subscribed to the channel, make sure to subscribe to Learn Overflow for regular LeetCode videos like this. The question is says like design your implementation of a circular tree. So we need to design the implementation of the circular queue. Fine. Now the circular queue is a linear data structure in which the operations are performed based on FIFO, first in first out principle, and the last position is connected back to the first position to make a circle, and it's called a ring buffer. Fine. So for this is one benefit of the circular queue is that we can make use the spaces in front of the queue in the normal queue. Once the queue becomes full, we cannot insert the next element even if there's space at the front of the queue. But using the circular queue, we can use the space to store new values, right? So if you remember, like if you have learned this, so circular queue is like a queue like this in this format. So usually a queue, if we look, a queue normally a singular queue is like this, where we insert values from the front and like first in, first out. Okay, so we keep on inserting values from the front, and also whenever we need to remove a value, we'll remove value from the first as well. Okay, so that's the FIFO format. So that's what it says, FIFO format. Fine. In this case, what happens? So, like in normal queue, once you just remove an element, we keep on adding element from the like we keep on adding element at the end. Fine. Say you just added all these elements, and then say you have this spaces blank, and after you add this position also, then you don't have any other space to fill. But once this first element got popped out or removed, this space gets blank, and in this case we need to fill our position as well, but that's not possible because like this position is filled, not the last position. We can fill on like place like insert something only at the last, right? So that's not a possible case. So what will happen in this case? So that was a kind of or a normal FIFO format or normal singular queue, fine, or the normal queue we have. Now let's understand circular queue. What happens? Say this is the front. Okay, I'm just marking it the front. Okay, and also this is the rear from that end, other end. Okay, so from the front we just inserted one value, two value. Okay, we kept inserted values, fine, and then at last we just inserted our last value as well. Fine. Now, once we inserted our last value as well, then we find some of our front values gets removed. Okay. So in that case, what will happen? We can now store our values in our this position because the last was over here, and then if I just move to the next, we are finding that the next position is also blank. Fine. So this is the concept of the circular queue. So we just keep like adding values from the last and once removing value from the first. So that's what we can keep on doing. Fine. Now, what we need to do here, we need to like design a circular queue. There you can see my circular queue is a function given to us. Like this is a function call like object creation call. Fine. And then this k being the length of the queue being given to us. Fine. In the like further, like there's a front function. This is a front, there's a rear. Right. These are two functions. This once we call this function, so whatever your front is, say this position is, it will return this current value back. Or if we call the rear, wherever we are rear is, say this position, it will return our dash position value back. Fine. In case like if the queue is empty, it returns -1. Fine. Now there's two more functions, enqueue and dequeue. So there's a enqueue and dequeue. So enqueue is actually adding value to the queue. Fine. So as we say, we keep on adding value. So that is done through our enqueue function, and dequeue function is removing value in the queue from the queue. Fine. And there is other two functions, that is empty and is full. Is empty denotes that's the like the all like the value is empty for us. Right. There's nothing in it in our like there's nothing in our queue, and is full means our value is filled, or like the queue is full and we cannot add more items into our queue. Fine. So that's the is empty and is full we have over here. Fine. Now the question is, we don't have anything like this circular format for us, right? So somewhere we need to try out something based on our like and single array format only, right? So how we can like go ahead and do that? Okay, so that's what we need to see, or that's the actual problem we need to solve over here. Fine. So say we have this array over here, fine. We'll take two pointers. One is the front, fine. Front, noting the front position or the current value or the front value of our like of our queue, and the rear, storing the rear value of our queue, or the last position where the value needs to be inserted. Okay, new values can be inserted. Now, say we got a few values in this format. Okay, we got few values in this format. What I mean, like, or say we just filled in all the values, and at last we find that the front from the front there are two other values which got popped up, fine, which got removed. Now we need to add more values, so we need to move our rear at the very beginning. Okay, how we can do that? This is the actual trick of this question, or this is actual trick. Like, our rear is standing at the length of the, like, whatever the length of our array. Okay, our rear is standing at the end. Okay, now we somehow need to move our hair at the front position to insert our next value, because the front have like spaces left, or blank spaces, right? So what we can do in this case, we'll do something like rear. Okay, so we'll do something like we are inserting value, so we are doing rear plus one. Okay, so where it will be inserted the next value, rear plus one. And with this rear plus one, we'll do a mod size. Okay, mod size, what it will do. So say size is the size of our whole array. Okay, so rear is at last position standing. So rear plus one is what? Rear plus one is the size of our array, right? So once we do rear plus one mod size, that immediately changes our rear to the index zero, right? So this is how it happens. Okay, this is how the values are stored. Now the same is true for the front. So say the front is getting removed one by one, and the front is somehow standing at the last position, and the rear is the next position. Okay, now after removing our next element, fine, if we remove an element, then in that case what will happen, this front need to be traversed to the next element, right? Say like a front, if the front is standing at the very first position, uh, after we remove an element, our front cannot be equal to size, right? Then we need to remove the next element onwards, fine. So what we'll do, we need to shift our front to the exact front as well. So what we will do in this case is basically like a similar concept, front plus one, mod size. Okay, so like mod size is a concept that will help us to again and again have a circular effect on this like exact what do you say, exact values. Okay, so if you are so confusing, it will be better if you just go ahead with some values. Okay, if you just check with some values. Now see here, in the example one, there's my circle is a function being called with value 3. That means the length is being 3. Right? Let me just clear this up so you'll understand. With the length being 3, so we got an array of length 3. Fine. 1, 2, 3. We got this array. Now we are enqueuing 1. So 1 in getting inserted. Fine. Our front is initially at 0, and front gets shifted to over here, like the next okay, not over here, sorry. Our like after enqueue, rear gets shifted, like we insert in our rear value. Okay, so rear was initially at index 0, now rear is over here, fine. So this is our rear, and our front remains over here, because if we need to remove an element, then we will remove from the first element, right? So our 1 gets enqueue, then again we got enqueue, and then 2, fine, we got an enqueue and then 2, then again we got an NQ, and then 3. Fine. We got an NQ and then 3. Fine. So you see, like the first 3 being null because it is just a length. then true, true, and then true. Fine. Next, we got another NQ. Fine, and we got 4. Now, see, after we inserted our rear, okay, after we inserted 3 over here, okay, so what we are left with, if we just check clearly, we are actually left with, say, front is over here, rear inserts here, and rear is standing at this position, right? Rear is standing at, like, uh, it should be after this array, that is equal size. So there it cannot stand, so officially it is standing at like index 0. Fine. So here is basically standing again at index 0. Now, what is happening? Once we see like rear is standing at this, so our array is full, right? Array is full because we will have another variable called the length. Okay, so that will store whether our array is full or not. So that will be is empty or is full. So we need to check. So once the array is full, we cannot do a further NQ. So that NQ or NQ of 4 returns as a false. Fine. Next, we call the rear. So rear function is called, and it returns us what's the last element? Our last element is a 3. Fine. So last element is 3, and that's what is got returned. Fine. And then if there is a call for is true, is it to is full? Yes, it's full. Then we do a DQ. Fine, we do a DQ, and in that DQ, what we're doing, we are like, we are not sending anything, right? DQ is like blank over here. Fine. If we are doing DQ, so that definitely means, okay, our one will get erased. Fine. And what else will happen? Our this front will be shifted to over here. Fine. Rear is already at the last, so front will be shifted to the next position. Fine. Now, our front got shifted over here, and then we are trying to do an NQ. We are trying to do an NQ, and where will be NQ of 4? Okay, so where will be this 4 will be stored? Our 4 is stored at this position. Okay, and rear again gets shifted to the next position. So that's the like the way it does. And then further it says call for rear, and call for rear returns as 4 because rear is storing this position. The call rear 4 is as our rear right now. Fine. So this is how the operation works. Like you understood how we are moving rear from the last to the front, or front from the last to the rear. Like these 2 pointers, how we're changing. It's simply using the use of like that modulus operator. Okay. So that's how we're doing. So let me quickly write down this code. This is not a very complex code. Let me quickly write this down, and you'll understand it further once we have our code in hand. Fine. So let's quickly go ahead and write our code. Okay, so there is this is like a like the solution we got, and as always, LeetCode has this issue. Anyways, that doesn't matter. So let's check out what we exactly see. So we initially took an like an array, and we got a few variables size, that is hold the size of our key, that is the size given to us, and then there were 2 3 variables like used will be storing how what is the current length of our values we have. Fine, is it equal to size or it is less than size? I initially used this 0, so that means we don't have any values. Next is front and rear. So front and rear all are starting at our like the initial positions at the initial indexes of our array, right? 0 and 0. Fine. And then what you're doing in our like in our constructor, what we are doing, we are simply assigning like initializing our array q equal to new int k, and then size equals k. So we are just initializing our values. Okay. Now let's first look at this is empty and is full. So what is this? So is full, how do we know whether it's full or not? So that basically means we have a used variable. Okay, if our used variable is equals to size, if this is equal, then it's full, right? So we are just returning whether whatever is the condition we have. Then what is empty? Is empty means if our used variable is zero. Okay, like how many values you have used is zero. That means it's empty. So that's what we are checking. Then when you're returning for front and rear, okay. So what is the front element? Front element is basically like we'll check whether it's empty or not. If it's empty, fine. Then we return -1. Okay, it's simply because of this like the front element. Front element is like if the queue is empty, return -1. Fine. So if the queue is empty, return -1. Else we need to return queue of front. Front started from 0, right? So queue of front returning our current position. But remember, before I like over here, you see like we are checking for is empty, okay? And if it is empty, we are returning like in the rear part. If it is empty, we are returning -1, and then we are just simply having values like q of rear -1 plus size mod uh, simply then mod of size. So that means what we, if you look carefully over here, I will explain it to you now. We have actually changed our position, rear position, after we have inserted. So once we are checking for the rear, so we need to check for the last element, right? So rear -1 plus size mod size. So this is taking us, say, rear was initially like before running this step, rear came back to 0, fine. So in this step, what we'll do, we are taking the rear back to its size -1 value, okay? So rear becomes 0, and see the rest becomes size -1. That is the last position. Okay, that mod size will return that value only. So this is the kind of approach we are taking. So this is the rear. Let me just like if it's confusing, I'll come over it over here later. Let's just explain this NQ and DQ, then this should be understandable. So in this NQ, what we are doing, we're checking whether it's full or not. Okay, NQ is we are adding value. So first we are checking whether our queue is already full or not. If it is not full, okay, not of is full, then what we are doing, q of rear, the rear, whatever the rear is initially at 0, so q of rear is value, we added it, and then we moved it one step further. So rear equal to rear plus 1 mod size. So it just simply in normal sense, it's just moving the next rear is moving the next blank space, okay? And then we marked used plus plus. So that means we used one space initially, fine, and then return true. That is we got our value. Else, if it is already full, we cannot add this to our, like we cannot add this value, so it simply return false. Now in the last part, so there we have DQ. So in this DQ, what we are doing, we're checking whether our array or queue is already empty or not. Fine. If it is not empty, fine. If it is not empty, in that case, what we are doing front equals front plus 1. Okay. See whether when we are deleting element from our queue, we actually cannot delete element. So if we delete element, what we will mark it? Mark it to 0 or something. So let's use this step, right? We just mark that our pointer gets moved to the next element and our number of used values reduces. Right? So if we mark that, it's done. No point just changing the value. Okay. Let the value there be as it is. We are not accessing it. We are just, whenever rear will come up to that position, rear will automatically write it. Just making note that used is not equal to size. Okay. So that means it's not full, so rear will automatically write it. So that's not a big deal for us. Fine. So what happening? We simply moved our front, okay, front to the next position, and then used minus minus. So we are just making sure that the total used spaces are getting reduced. Okay, so that's it we're doing. Now, if you look carefully, in like in queue, when you are adding values, we are first adding the values, then moving our rear pointer to the next place, right? So that was the case happening over here in the rear. When you are checking for the rear value, okay, so what happening when you're checking for the rear value, we actually need to check for like this value in this format. Okay, so what it means, so rear is store, like currently if you look after NQ, rear is has already moved to its next position, right? So we need to access the previous position, so that's rear minus 1. Fine. In normal sense, we need to access the previous position, that's rear minus 1. Fine. So in that, with that, we need to add a size just to make sure that in case if it don't go underflow, that means it don't go out of our array. Okay, say rear currently is at 0. Okay, so the last position or the rear position where the value got added is like size minus 1, right? So in that case, what we can do is basically like uh, rear is currently at 0, so we are just see what we are left with size minus 1. So this is what we are trying to achieve with this step. Fine, we're just taking it back to origin position. So mod size is basically taking it back. So I hope I can make you understand how this question is done, and how you can actually solve this question. And this is a pretty fast solution. Ignore that lead code. You can actually do it in 3ms. I'll put the solution in the description as well. You will find the link to in the description. So make sure to do that, and you will find if you face any kind of difficulties, make sure to comment them down. I'll be happy to help you out in this question as well, in the comment section as well. Fine. So also like this video and share it with your friends who are doing today's LeetCode problem. So thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.